So welcome to this segment. If you are either a Form 1 or Form 2, you may find these questions particularly interesting and important for you. So notice some of the questions that were written by some of your friends. So if you want to revise with Mr. Nyendo, no problem. It says two children are sitting on opposite side of a seesaw. A 300 Newton child sits 1.5 meters from the pivot. Another child sits 2 meters from the pivot. Then A, draw a clearly labeled diagram to show the arrangement of the seesaw. So that is what they want you to do there. So basically what you could have done is that as I'll use a pen, you can use a pencil if possible. I'll simply draw a seesaw, usually a plank. So I'll draw a plank like that. Then I'll definitely put up somewhere a pivot. I'll put up a pivot there. That's the point of support. So I'll put up a pivot there. So that's what you do. So that's a plank. Then they told me a 300 child sits 1.5 meters from the pivot. So let me say maybe from the pivot here to somewhere here, let me say that this child who is actually 300 newtons. So you need to indicate clearly that the distance from here to there is actually 1.5 meters. That's the correct way of actually doing it. Then from here to there, you can see the distance should slightly be longer. That's why I put my pivot strategically. I don't know, there's another child here, probably having a certain weight, which we don't know. That is representing the weight of the child, but sits in this case from the pivot, to where the line of action of the force is acting at 2 meters. So the distance you need to clearly indicate. For you to be given these 2 marks, you need to clearly indicate, and this is representing the pivot, of course, the point of support which is there. And that's what you needed to do in order for you to earn the 2 marks there. Then B says calculate the moment produced by the first child. So remember, moment is equal to force multiplied by distance. So moment is equal to, what's the force? The first child is actually 300 newtons times the distance from the pivot to where the force is, or the child is seated, which is 1.5 meters. So meaning moment will be equal to, so if you look at this moment going in this direction, this is what we call as being the that's the anti-clockwise moment. Then the moment going in that direction, this is what we call as being the clockwise. That's the clockwise moment. So you don't need to forget. So if you multiply, 300 multiplied by 1.5, that will give you 450. Remember, Newton meter, and that's the correct thing. So remember, the units are very important. Otherwise, you might have actually gotten your 1 mark wrong. So that's what you needed to indicate. Then C, calculate the weight of the second child required for balance. Now, since you want to balance up, they want you to find the weight of the second child for it to balance up. So meaning you are going to apply the principles of what? The principles of moment, which tells us in this case that, for example, if F1 times D1 is equal to F2 times D2, if you wanted, you would have used that one direct, but I want to show you. Let me say this is my F1 and that is my F2. It means this will be my D1 and that will be my D2. So my F1 there is simply going to be 300 multiplied by 1.5, which is equal to force 2, which is the weight of the second child, we don't know, times the distance from the pivot to there, which is 2 meters. So you divide by 2 meters, you also do it the other side. This was meter and that was in Newton. So this and that will cancel. Remember what that gave you on top when you multiply to give you 450 newtons, because this one had newtons there, divided by 2, which is equal to W. Therefore, W will be equal to, so it is simply going to be 450 divided by 2, which is giving us a 225, and that is in newtons. And that's what they wanted you to calculate. Therefore, I can simply say, weight of, second, child is 225 newtons. So don't forget the units. Units are very important because they help to identify the physical quantity that you are talking about. That's what we say. Then state the condition for equilibrium. So now for this to be in equilibrium, what condition is there? Of course, you need to remember that clockwise moment, so clockwise moment, must be equal to anti-clockwise moment. So that is the condition that is needed for it to balance up. So moment anti-clockwise must be equal to moment clockwise about the point we're simply calling as being the pivot. Then E says state two everyday application of principles of moment. There are a lot of them. One, you can simply talk about the seesaw. It is very much possible. Then you can simply talk about using a spanner, to turn a nut. You could have talked about that. Opening, you could have also talked about opening a door using a doorknob. So it is possible using a bottle opener. Please watch out as we come and consider question number 2 together in the next video.